Hello, grade 8. This is Mrs. Lopez, lesson 4, numbers raised to the 0th power. Well, first look at this word, 0th. That's the word we are going to use when describing powers of 0. Okay? A number is raised to the 0th power. Before we get to that 0th power, I would like to remind you our three formulas that we know. Four actually. One is missing here. X to the mth times x to the nth, we have the same base. We are multiplying exponents here. So instead of multiplying, we are going to add the exponents. And for example, if I have 2 to the third times 2 to the fifth, I'm going to add the exponents and do 2 to the power of 3 plus 5 and keep the base number. Nothing is changing that. This is 2 to the power of 8. Our second formula that we used was x to the mth power to the nth power. So we are raising a power to a power. We are multiplying the exponents. For example, 2 to the third power raised to the fifth power will give us 2 to the power of 3 times 5, which is 2 to the 15th power. Third formula that we used was when we have multiplying two numbers and then raising it to the exponent. And that means that I can take each factor inside of these parentheses and raise it to the same exponent. For example, when I have 2 times 3 to the power of 5, it's the same as if I raise 2 to the power of 5 and multiply it by 3 raised to the power of 5. I cannot simplify it any further because I have different bases going on here. We also learned the division ones, and those would be, let's write it down here, if I have x to the power of m divided by x to the power of n, I would subtract the exponents because I have the same base. It will be x to the power of m minus n. For example, 2 to the power of 5 over 2 to the power of 3 will be the same as 2 to the power of 5 minus 3, which is 2 to the second power. If I have 2 to the third power over 2 to the fifth power, I will have to take away 5 from the 3, and that will be negative second power. Let's look at the other one that we used. X to the x over y to the nth power. This is also a division problem. It also looks like a fraction. We have different bases here, so there is no way we can do anything with the exponents, but we can write down it as x to the nth over y to the nth. These are the 5 formulas we learned. Let's look at the example. 2 thirds to the fifth power can be written as 2 to the fifth over 3 to the fifth. Okay? So now, what is that 0th power? Let's write 8,374 in exponential notation, but first we need to write the expanded form of that number. So we know that it's 8,374. How can I write it in expanded form? So I'm going to write 8,000 plus 300 plus 70 plus 4. Okay? So now how can I write it in exponential notation? Since I have 8,000, it's the same thing as 8 multiplied by 1,000. How can I write 1,000 in exponential notation? 10 to the third power. So I have 8 times 10 to the third power. Then I have my plus sign. 300 I can write as 3 times 10 to the second power. Now I have my other plus sign. Now I'm writing 70. 70 is 7 times 10 to the first power. And then I have 4. How do I write 4? 4 is 4 times 10, but then to what power am I going to put that? Well, I have a pattern going on here. 3, 2, 1, and now it will be a 0. So what is that number, 10 to the 0th power? What does it mean? If I'm adding 4 multiplied by 10 to the 0th and I'm still getting a 4, what does that number going to mean? Since I'm multiplying 4 by a number and getting it the same number 4, this 10 to the 0th has to be the 1, right? Because I know that 4 times 1 is itself. 4 times 1 equals 4. So that means that 10 to the 0th has to be the 1. And that is so true. Any number to the 0th power is 1. I would like to write it down with you somewhere. Let's put it right here. Any number raised to the 0th power is 1. Any number raised to the 0th power is 1. For example, 5 to the 0th power is going to be 1. 100 to the 0th power is going to be 1. -3 to the 0th power is going to be 1. 2/3 raised to the 0th power is also going to be 1. Any number to the 0th power is 1. Let's try it out again. I have 6,900,085 and 62, 85. 6,985,062. I want to write that expanded form in the exponential notation. Let's try it out. So I have 6 million plus 900,000. Then I have 80,000. Then I have 5,000. Then I have 0. Then I have 60. Then I have 2. Let's write that in exponential notation. 6 million is the same as 6 times 10 to the 6th power, because million has 6 zeros. It means 10 is multiplied by itself 6 times. So 6 times 10 to the 6th power plus 9 times 10 to the 5th power, 50, 5th power. Then I have 8 times 10 to the 4th plus 5 times 10 to the 3rd, 5,000, 10 to the 3rd. Then I have plus, I don't have to worry about the 0, but I can still write it so we can see the pattern. 0 times 10 to the 2nd, any number times 0 is going to be 0, plus 6 times 10 to the 1st, and now I'm stuck with the 2 again, plus 2. What can I multiply 2 by that will result in 2? By 1. 2 times 1 is 2. So, and according to our pattern, we need to continue on the 10. So it was 10 to the 6th, 10 to the 5th, 10 to the 4th, 10 to the 3rd, 10 to the 2nd, 10 to the 1st, times 10 to the 0th. Done. So we know that any number raised to the 0th power is 1. Let's take a look at our exercises. So I have 3 to the 5th over 3 to the 5th times 5 to the 0th power. All right, so I have, according to our rules that we learned in the previous lessons, I have the same base, I have division problem, and I have exponents. What do I do when I divide numbers with the same base and different exponents? I subtract the exponents, just like in the rules that we learned. So I have 3 to the power of 5 minus 5, multiplied by 5 with the 0th power. So 3 to the power of 5 minus 5. What is 5 minus 5? 0. So I have 3 to the 0th times 5 to the 0th. Notice I have different bases. It seems like I can't do anything with it, but I know that any number risen to the 0th power is 1. So it basically 1 times 1. 1 times 1 is 1. Okay? Let's look at exercise 4. 7 to 17th times 1 over 7 to 17th. Before I get to do this, let's remember basic fractions. How can I multiply numbers, whole numbers, by a fraction? I can always put it over 1, right? So I can now multiply the numerators and the denominators. Any number times 1 is itself. We know that. So I can write 7 to the 17th over 7 to the 17th. According to our rule learned in the previous lessons, we have division of the same base, different and actually same exponents. Any number over itself, we already know it's a 1, but also 7 to the 17th minus 17 is 7 to the 0th. This is 1. Another proof right now that you just heard from me, any number over itself is 1. So for example, 5 over 5 is 1, 3/3 is 1, right? And that goes for the exponents as well. This is just number raised to the exponent. It's a big number, but any number over itself is 1 whole. Okay. Let's look at exercise 5. X to the 5th times x to the 0th times x to the 2nd. I have the same base and I'm multiplying these numbers. So what do I do with exponents? I add them. So I have x to the power of 5 plus 0 plus 2 equals x to the 7th power. Okay. Exercise 6. Now we are looking at the power raised to the power. And notice how interestingly it's written. We have parenthesis inside the parenthesis. It's not difficult at all. You just need to look at what you're going to do. So basically what I have here is 6 times 4 to the 3rds, and that is to the 0th power. Okay, that's what really is here. They use parentheses here just to show you multiplication. And we know that we can use parentheses for multiplication. So I just rewrote it so it's a little bit clearer to you. That means, according to our rule, I can multiply each factor, raise each factor of the parenthesis to the power. So I can have 6 to the 0th power times 4 to the 3rds multiplied by the 0, just like we learned in our previous rule. So I have 6 to the 0th times 4. What is 3 times 0? 0. 4 to the 0th. Seems like there is nothing to be done. However, I know that every number risen to the 0th power is 1. So it's basically 1 times 1 equals 1. Okay? Let's see what's happening here. Oh, that's the problem set. So all I need you to do is just to show your work and see how that zeroth power works on the numbers. Okay? And I will see you in class.